Okay, so in this video we're continuing to work with univariate data. So far we've looked at, we're looking at different ways of representing that data. We've looked at bar charts, which would be used for categorical data. We've looked at histograms, which would be used for numerical data. And here we're going to look at dot plots and stem plots, which would also be used with numerical data. Although you can, we'll talk more about that later on. I was going to say you can sometimes, particularly for the stem plots, be dealing with perhaps two categories and numerical data, so you can be comparing two variables. But for now, we're just going to think about them in the context of numerical data. You need to have at least one numerical variable anyway. So a dot plot is a really quick and easy way to represent discrete numerical data. So this wouldn't work for continuous numerical data, and nor would the stem plot, so both for discrete numerical data. The resulting plot is really similar to a histogram or a bar chart, but it's easier to actually produce by hand because you don't need to kind of formulate the frequency table before you can then build the bar chart. You just add the dots on as you work through the list of data, and then voila, you've got a plot. Let's have so there's an example of a dot plot above there. So this is showing us that, there's scores along the bottom, and 3 people or teams or whatever scored 7, 2 teams scored 10, the highest score achieved was 12, the lowest score achieved was 3, etc. Okay, so here we have data that represents the number of hours each week that 40 teenagers spend on household chores, and we want to display the data as a dot plot. So the first thing you've got to work out is your scale. So you need to think about your data and the values that it spans. So 0 is clearly the smallest value. There's no negatives, but there are zeros. And then the largest value, they're mostly single-digit numbers, except there is a 10 there. So we will need everything from 0 to 10. So we're going to draw ourselves a horizontal axis, use a ruler. It's going to run from 0 up to 10. I'm just going to count, see how we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so fairly nice even scale. If you can't do that relatively accurately by eye, use a ruler. 10, 9, 8, 7, sorry, lost track of counting backwards there. 6, 5, 4, 3, 2, and 1. And we also need to obviously identify what those values represent. So these are hours. Okay. Or, study hours, hours on chores each week, but the values represent hours. Okay, so then you can simply work your way through the list. So rather than in order to make a histogram, we first of all have to be able to work out, how many 2s are there, and work out all the frequencies. Here we don't have to, we'll simply just put it on the plot as we come across it. So the first piece of data is a 2. Once again, I'd strongly encourage cross it off as you put it on the plot so that you don't accidentally count it twice or accidentally miss it. Okay, so that's my first dot. 5. It's really important that things are nice and lined up. If I drew this as a bigger dot than I did for the one at the 2, or if I draw it higher up, I'm already giving a misleading sense that, if you would think about, the plot, it looks like there's more in the 5 category. So it's really important that you are even and careful about how you draw them. 5, then we've got another 2, and we've got a 0, and we've got an 8, 7, another 8. So again, we want to maintain the same spacing that we used with the 2, and then we want to be really consistent about any future spacing. So we don't want dots to sort of, unevenly space as they go. We want really systematic, ordered spacing. Okay, so that was the 8. All right, I'll just pause the video while I continue to plot the points. Okay, so there's my completed dot plot. So again, just being really consistent about nice even spacing between your dots, nice even size of the dots. Otherwise you're going to give, as I said, a misleading sense. If you've got a dot plot where in this value the spacing's uneven, or even if it's not uneven, but if it's more spaced out in one. So here, if you were to sort of think about, you should be able to basically do this, and you've then got the histogram. or the bar chart. Do you know what I mean? So it's really important that they give a relative sense of the fact that one is taller than the other. So if, for example, you've got this, they've actually got the same number of data points in them, and so it's really misleading. So you must take care when you're plotting out the plot to make sure that you're giving an accurate picture of the data. So from the dot plot, we could tell that the modal number of hours spent on chores each week by these 40 teenagers is 2 hours. We can see that the range of the data is 10 hours, that is max minus min, 10 minus 0. There's no real clear shape to the plot. It's not, sort of symmetric. There's not really clear skew either, actually, because there's a bit of a peak up here at 8 as well as at 2. Sometimes that might be called kind of bimodal data with sort of 2 peaks. They don't have to be perfectly the right height, as in there's sort of roughly two modes, and everything else is kind of similar. Yeah, so that's a dot plot. Nice and quick and easy to construct, as I said, because you don't need to kind of organise or sort the data first. You can just plot each point as it comes. Okay, so the other representation we want to look at here is stem plots. So again, these are going to be discrete numerical data, but really only for small to medium sets of discrete, well, or continuous, but really it would have to be, yeah, it can be continuous, because as long as the data is sort of rounded to the nearest whole number or to the one decimal place. But you wouldn't want an enormous set of data to make a stem plot. So generally small to medium sets. If you had a big set of data, you'd want to group that data and use a histogram. Okay, so the example that's already drawn here is the ages of people attending an advanced computer class are recorded below. Okay, so there's 15 bits of data there. The stem plot for this data is shown opposite. Okay, so the first thing we need to understand is every piece of data is going to be broken into a stem and a leaf. Now the leaf can only be one digit, so the leaf has to be the last digit. Now it's important that that last digit represents the same units. So say, for example, if we had, obviously these are ages, but let's say it was a different kind of data, and let's say this data also included the number 12.1. This wouldn't be a good set of data for a stem plot if it did, okay? But just for example, the fact that just one piece of data has a 0.1 means that the tenths, which is the first digit after the decimal place, would need to make up the leaves. So we'd need to think about all of these other numbers as being 0.0, and each of these would have a leaf of 0, and this one would have a leaf of 1. In this case, they're all 2-digit numbers, so the last digit is the units digit. Those digits are going to be the leaf, and then the other digit will be the stem. Now it's quite possible, let's say we had a very elderly person in the advanced computer class who was 103. In that case, again, the units digit is the leaf, so the 3 would be the leaf, and this number would have a stem of 10. Okay, so we'd continue the plot and there'd be a 10 down here, so 6, 7, 8, 9, 10, and then we would have one leaf down here. Okay. So you can have a 2-digit stem, but your leaves can all only be 1 digit. So we draw a line and we list all of our stems. Now you'll notice when I added on the 103 here, I didn't just add 10 onto here and then put 3, because that doesn't give me the sense of the shape of the distribution. You should be able to see that if you basically turn this on its side, you get the histogram again, like we did with the dot plot. Except you didn't have to turn on the side of the dot plot. So this shouldn't be abutting onto there. Again, you need to make sure that if your lowest stem is 1 and your highest stem is 10, then you must include every stem in between that. Okay? So you get your plot. So you need to, that's the first thing you've got to identify. What are the leaves? What are the stems? What's the smallest stem? What's the biggest stem? And then list all the stems. Okay? Then next to each stem, you put the corresponding leaf. So we look at, okay, we're looking at, these are all the numbers in the tens. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we're looking for any of those values. We've only got 16, so we just put the 6. But then we're looking for any of the digits, any of the numbers in the 20s. So from 20 through to 29. So we've got 22, we've got another 22, and we've got 23. Now the stems should be listed in order. So 2, 2, 3 rather than 2, 3, 2 or 3, 2, 2. Okay, so in order, numeric order. increasing numeric order. So then we're looking for the 30s. Okay, well there's, 1, 2, 3, 4 numbers in the 30s. So the smallest leaf is the 0, then the 2, then the 4, and then the 6. Okay, and list them out. Once again, like the dot plot, making sure that things are evenly spaced is important. Okay, it's really important that each of these columns of data is evenly spaced, because again, it's giving us a sense of the scale, giving us a sense of, there are more pieces of data in this group than there are in this group. If you unevenly space the numbers, if you were to draw this and have 1, 2, 3, 4, 5, 6, and do, 2, 2, 3, and then 0, 2, 4, 6, again, you've got these two looking like they've got the same number of pieces of data in them, but actually this one should be longer than this one. Okay, so making sure that things are evenly spaced. You certainly wouldn't draw in these lines, but you really want to think about, the first digit in the first leaf should all in each stem should all line up. The second leaf should all line up. The third leaf should all line up. The fourth leaf should all line up. It's really important. Now, the other thing a stem plot needs is a key, because we need to be clear about what sort of digits, what place value do the leaves represent, and what place value do the stems represent. Okay, so in this case, 2/2 represents 22, and we've also got units here, so I'm going to be clear that it represents 22 years old. Okay, if it was a whole different set of data, and these were 2.2, 4.7, 3.0, 5.7, etc. Okay, then the stem plot would look exactly the same, but the key would say 2/2 line 2 represents 2.2, and then whatever the units are, for example. So the key is essential. It's an essential part of the plot. Okay, then I've got another plot here. So sometimes the data might be such that the stem plot, sorry, I didn't mean to bang the mic then, that the stem plot doesn't reveal very much. So here, when we look at this, actually, when we break the stem, we look at the data, it's clearly all between 60 and 80. So when we group it with the tens digit here, it just goes into two groups that are pretty similar in size. So it's not really telling us a lot about the data. We're not getting a sense of the shape, and etc. So in this case, we can split the stems, and it's conventional to split the stems into halves or into fifths, and that's because 2 and 5 both go into 10. Okay, so if we were to split it into halves, what that would mean is we would create 2 stems for 6 and 2 stems for 7, and essentially this would be all the numbers between 60 and 64, and this would be all the numbers between 65 and 69. Okay, sometimes people make the mistake of including 65 in here. It's really important that you've got the same number of options in each category. So 60 to 64 is 5 different numbers: 60, 61, 62, 63, 64, and 65 to 69 is 5 numbers. This category would be everything between 70 to 74, and this one would be everything between 75 and 79. Okay, so by just breaking things up a little more, again, this particular data set, it still doesn't really tell us much. We've still got 2 big groups lumped together in the middle. All that did was separate out 1 bit of data and 1 bit of data. So we might go a bit further and split it into fifths, in which case we would have 5 stems starting with 6 and 5 stems starting with 7. And each of them represents now only 2 data values. This would be 60 and 61. This would be 62, 63. 64 or 65 would go in here, 66 or 67 would go in here, 68 or 69 would go in here. Okay, so here you've got, for each stem, you've got 2 groups of 5 possible values. Here you're going to have 5 groups, each with 2 possible values. Okay, and when we do that, we get the data a bit more spread out. We're still seeing it really is very closely congregated around between 66 and 73. But it wasn't as easy to see that here, that it was actually quite closely congregated between 66 and 73, as opposed to, it looking like it's just very closely congregated from 60 to 80 or 79. Okay. Again, we need the key. But yeah, so generally speaking, you won't make the decision to divide the stems into halves or fifths. You'll only do it if you are instructed to do it. Okay, so let's have a look at some examples. So here we have the money correct to the nearest dollar earned each week by a busker over an 18-week period is shown below. So this is telling us we have 18 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9 columns by 2 certainly confirms 18 pieces of data. Okay, construct a stem plot for the busker's weekly earnings. Okay, so we want to look at our smallest and largest values. So we've got 5 is the smallest value. I think the largest is 60. Okay, now because all the numbers are 2-digit numbers, we want to think about 5 as being 0, 5, because we're going to use the units, digits, as the stem, sorry, as the leaves, which means for the 5, the tens digit will be a 0. So the smallest stem is 0 up to the biggest stem, which is 6. So we're going to have 0, 1, 2, 3, 4, 5, 6. Again, don't cramp up your stems, give them space, make sure they're evenly spaced. And then we can work our way through the data. So I'm looking here for any single digit numbers to go in the top row. There's only the 5, so it's going to be 0, 5. Okay, then we're looking for numbers in the teens, in the tens. So we've got, I'm just going to circle them first and be clear that I don't miss any. So we've got 11 and 18. So those stems in order, we're going to put the 1 first and then the 8. Now again, give it space. Don't squash your 8 up here. Give it nice even spacing. You want to kind of imagine, you know, your separate columns. Give them nice even spacing. And then, you know, even, you know, rule a light pencil line there if that helps you, so you can keep them all lined up. Okay, so we've done the 11 and the 18. All right, now we want the, oh, sorry, I missed a 19 as well. Lucky that's in order, so there's going to be a 9 there. Okay, numbers in the 20s, we've got 27, 23, and that's all. So 3, 7. If you've got a slightly larger set of data than this, I would suggest it's worth actually ordering the data first. It will help you to avoid those errors like I just did there where I'd actually missed 19, because the problem is if I got to the end and realised 19's not an issue because I could add it on to the end of the row. But if I realise, let's say, that I'd missed the number 14, I can't just squeeze it in there because I'm losing the sense of how long that row should be. I would have to move the 8 and the 9 along, okay? So it's really important that you don't miss any numbers, so it can be worth investing the time at the beginning to reorder the list, put it in numerical order, and then from there create the stem plot. You can get your CAS to order a list of data. I might show you how to do that, but honestly, by the time it takes you to type a list in, I don't usually recommend it. Okay, so then we're looking for the numbers. So we've done the 27 and the 23. Now we're looking for the numbers in the 30s. There's quite a few. So we've got 35, 36, 32, 39, 37, 31. Okay, so we've got 1, 31. We've got 32, yes, 32. No, 33, 34, 35, 36, 37 and 39. 7 and 9. Okay, trying to maintain even spacing between the numbers. Alright, so we've done all of those. Now we want the numbers in the 40s. We've got 42, 45, 41, 43. Okay, so we've got 41, 42, 43 and 45. So 1, 2, 3 and 5. Oh, I've just realised I've missed a 29. Hopeless. Okay, but again, lucky it goes on the end. 29. And then there's nothing in the 50s, but there has to be the 5 stem. That's important. And then we're going to have 60. I'm going to get rid of those. Not quite complete because I need my key. Sometimes it's a good plan to write the key in first. It's an easy thing to forget at the end. You get to the end of having got all your data on there and it's like, great, done, moving on. But you'll have forgotten the key. Usually I'd pick a data value out of the plot to give us the key. I don't love giving a 0, 5 as the data point, so I might choose this 2, 3. I also don't like the 1, 1 when I write that as a key. It's going to be, you know, 3 lines. It's a bit confusing. So I'm going to use the 23. But it doesn't have to be a data point. It can be anything. 2/3 means, what are the units here? They're in dollars. $23. Okay. Doesn't mean $2.30, it means $23. Nor does it mean $230. Okay, question 3 here. The heights in meters of members of a basketball squad are given below. The data has been ordered, so it's already in order here. That helps, that makes the stem plot construction much more efficient. Construct a stem plot for this data. Okay, so again, it's going to have to be, they're all numbers to 2 decimal places. It's going to have to be the second decimal place, the hundreds digit, that forms the leaf. Okay, so the stems are actually going to be quite closely grouped together. They're in order, so 1.8 is the smallest stem, or sorry, we won't write 1.8, well, it'll be 18, and then 22 is the biggest stem. So no decimals in the stem plot, so it'll be 18, 19, oh, sorry, I should have written smaller than that, or higher, started higher up, 18, 19, 20, 21, 22, so we've got 5 stems. The data's in order, so we can then just go through and list our leaves. So for the 18, we'll have 5, 7, and 9. 5, 7, 9. For the 19, we'll have 1, 5, 6, 6, 7, 9. 1, 5, 6, 6, 7, 9. Got a bit out of whack there. 6, 7, 9. The 20s, 1, 3, 3, 5, 9. 1, 3, 3, 5, 9. And 21, there's just the 1. 7 and 22, there's just the 1. Okay, so we definitely need a key. So I'm just going to go with that first number, 185, means, now what does the data represent here? Heights in meters means 1.85 meters. Okay. Alright, question 4. LeBron James scores in 16 consecutive games are shown in the following stem plot. Produce another stem plot for this data by splitting the stems into halves and into fifths. Okay, so into halves we're going to have 2 stems for each value. So we're going to have 2, 2, 3, 3. And then, so in the first stem it'll be everything from 20 through to 24, so that'll be the 0, 2, 2, and then everything after that goes in the second half. That's 5, 6, 8, 8, and then the 3s, so again everything from 30 up to 34, so those 3 3s go there, and then the rest 7, 7, 8, 9, 9 are in the second half. Alright, so there's my stem plot divided into halves. We still need the key. So 2/0 equals 20, or means 20. What's the units? Points. There, it's his score in a basketball game. Means 20 points. Alright, then if we split the stem plot into fifths, we're going to have 5 stems of 2 and 5 of 3. So 2, 2, 2, 2, 2, 3, 3, 3, 3, 3. Okay, so each of those can only take 2 different values, so 20 and 21 in the first value, so there is a 20, 22 and 23, so there's 2 22s. So I'm just working my way through the list here. Okay, we've done the 20, we've done the 2 22s, then it'll be 3 and 4 in the next list, there's none of those, 5 and 6 in the next, and there is a 5 and a 6. 7 and 8 in the next category, so we've got 2, oh sorry, I've lost track, oh no, 0, 1, 2, 3, 4, 5, sorry, should have been 4, 5 in the second group, so the 5 goes there, 6, 7, so just a 6, and then 8, 9 in the last category, so 2 8s. Alright, then the 3, so 30 and 31, there aren't any, 32 and 33, yes, there's 3 33s. Again, try and keep things lined up vertically. So, oh, sorry, I changed the highlight. So, okay, probably might just move that one in a bit. That's not as far away. It's further away, sorry, than the other one, so we kind of want to stay fairly even. So we had 30, 31, 32, 33, 34, 35 in the next category, there's none of those. 36 and 37, there's two 37s. And 38 and 39, so 8, 9, 9, 9. Okay, so there's my stem plot divided into fifths, and we're getting a better sense of how that data is actually spread out from 20 up to 39. Again, we need a key, sorry. 2/0 means 20 points. Okay, this work is in exercise 2A, dot plots and stem plots.